Happy Monday morning. Behavior of polynomial functions last time. We need to look at how to find the zeros. To start, we look at dividing polynomials. Are you familiar with the division algorithm? The answer is yes. You just don't know that it's called that. You've been using it since you've learned division. The division algorithm states that for every pair of integers m and d, there exists unique pair of integers q and r such that m is equal to d times q plus r, where r is between 0 and d. So it says that for every pair of integers m and d that you're given, there is a unique way to write m as d times an integer plus an integer. And this terminology should be familiar. M is your dividend. D is your divisor. Q is your quotient, and R is the remainder. The process of dividing that you went through in elementary school was to find your quotient and remainder. Again, division algorithm simply guarantees the existence of them, doesn't tell you how to find them. We now extend this notion to polynomials. And is practically identical. Given any pair of polynomials, f of x and d of x, there exists unique polynomials q of x and r of x, such that f of x is d of x times q of x plus r of x, where the degree of r is between 0 and the degree of d. What is a degree 0 polynomial? What kind of function is that? What kind of function is that called?
Which is constant.
Yep. Degree 0 polynomial is just the constant function. F of x is your dividend. D of x is your divisor. Q of x is your quotient. R of x is your remainder. Once again, all the algorithm is saying is that the integer or the polynomials Q of x and R of x are guaranteed to exist. And they're guaranteed to be unique. It doesn't say how to find them. So, what does it mean to say that Q of x and R of x are unique? So given the pair F and D, what does it mean for the pair Q and R to be unique? What does unique mean in everyday language? Special is a little different.
I can do that.
The only one, right? Same meaning. So given your pair F and D, the pair Q and R being unique means it's the only pair that satisfies that equation. You can't have more than one pair. So now the question boils down to how do we find them? So think back. Elementary school. When was division? 4th grade? I think that's when you learn multiplication tables. And division's just the opposite of multiplication. How'd you find your quotient? Right, so if I ask for something like 29 divided by 3, how would you find your quotient and remainder? That's actually kind of an easy one. Let's do one that's a little more interesting. 2,897 divided by 3. How would you find your quotient and remainder? What's the process called?
number again, sir?
2,897.
Divided by 3.
Your 2,897 is your dividend, the 3 is your divisor. How did you find your quotient and your remainder?
In like 4th grade, have you do that? Long division.
Long division. Remember that? How do you think we're going to find the quotient and remainder of polynomials? Long division. Specifically in this case, it'll be called polynomial long division. There is another method.
It's like where you put it in like the box thing.
What box thing?
I forget. Like there's like a half a rectangle.
It's called synthetic division. There's only one problem with synthetic. It only works for special cases. Specifically, when your divisors of the form x minus k. Synthetic makes it easier in the sense that when you perform synthetic division, it's only the coefficients that you use. Going back to integers, what did it mean for a number m to be divisible by a number d? So again, in this case, would you say that 2,897 is divisible by 3? Why not? But why is it not? Why do we say it's not divisible? What does it mean to be divisible by 3?
Whole number. 3 doesn't go into a perfect certain amount.
What does it mean to go into it perfectly?
Whole number. Without any remainder.
Well, Q and R are whole numbers. Your remainder is 0. That's what it means to be divisible. In which case you would say that 3 is a factor. Right? And of course there are special rules for certain integers, like the rules for the powers of 2. Rule for 3, sum of the digits is 3. Rule for 9, sum of the digits is 9. Rule for 6 is divisible by both 2 and 3. Right? The rules for powers of 2 are really cool. For each power of 2, your number is divisible if the last n digits are divisible. So for 8, you look at the last 3 digits of your number, because it's 2 cubed. 16 would be the last 4 digits, it's 2 to the 4th. 4 would be the last 2 digits, 2 squared. So you can look at 128 and know that's divisible by 4, because 28 is divisible by 4. There's also rules for 7 and 11. I just don't remember them off the top of my head. So what would it mean for d of x to be a factor of f of x?
You can divide f of x by d of x with no remainder.
The remainder is 0. Right, we don't really typically say that f of x is divisible by d of x. We would just say that d of x is a factor of f of x. So remainder of 0 is going to be very important. On Wednesday, when we study finding the zeros. Being asked to find the quotient and the remainder. So d of x is 2x minus 3. Would we be able to use synthetic division?
Yeah.
Technically, no. What's the form for synthetic division? Is this x minus a number? Is it? It's 2x minus a number. That's not x minus k. So no, we can't use synthetic. Uh-huh. Not directly. There is a way to use synthetic here. You can factor out the 2. Be left with x minus 3 halves. But then you have to do weird things to your quotient and remainder because you factored out that 2. So for our purposes, we're not going to do that. We're going to stick with it has to be in the form x minus a number. That means we only have one option. We have to use long division. How did you do long division with integers? I probably have to go back to the elementary school language as well. So what was the process of long division before calculators? So how would you set it up? Because there was a setup.
We put the divisor on the outside, right?
Outside.
And then you do the little
Outside of what?
outside of division. I don't know what it's called, but is that
I think they call it a house or something.
outside of the house? Yeah.
I don't even know what its actual name is, to be honest. And then it was what? You look at how many times the divisor went into the first digit.
Yeah.
It's something very similar here. Look at the leading terms. How many times does the leading term of the divisor go into the leading term of the dividend? Another way, what do you have to multiply the leading term of the divisor by to get the leading term of the dividend? X squared. Now multiply your divisor by that. Subtract it. Two x cubed minus 2x cubed is 0. 3x squared minus negative 3x squared.
Is what? 6.
6x squared. Then it's negative 13x minus 0 and 5 minus 0. Is that degree less than the degree of the divisor? No, then you have to keep going. So you play the same game. Your new leading term is 6x squared. So what are you multiplying 2x by to get 6x squared? Multiply the divisor by 3x and subtract it from the new dividend. Negative 13x minus negative 9x. What was it? Negative 4x. You added them, not subtracted. And then 5 minus 0 is 5. Look at that degree. Is it less than the degree of the divisor? So you have to keep going. Negative 4x is your new leading term with a dividend. What do you multiply 2x by to get it? Five minus 6. Is that degree less than the degree of the divisor? So you're done. There's your quotient and there's your remainder. Not a hard process, but it is tedious. Especially if you get larger degree polynomials involved. What do you mean?
Like this is n dx divided by 2x minus 8.
Could be. Process is the same. Oh. Ask, and you shall receive. Now everyone's wondering if you're a plant. I have done that. I put a plant in my class. Would we be able to use synthetic here? Most certainly not. This is cubic, not linear. So right off the bat, it's a no. That means we have no choice. We have to use long division. Until you get a really good handle on this, on long division, I'd recommend leaving those gaps, or better yet, now it's the gain. What's the leading term for the dividend?
Rejects the
3x to the fifth. What's the leading term for the divisor? Go ahead.
X cubed.
What are you multiplying x cubed by to get 3x to the fifth?
3 squared.
What is it?
Is it 3 squared?
3x.
3x squared.
3x squared.
3x to the fifth minus 3x to the fifth is 0. 0x to the fourth minus 0x to the fourth is still 0x to the fourth. Negative 7x cubed minus negative 3x cubed. Negative 7 minus negative 3 is what?
Negative 4.
5 minus 6.
Negative 1.
Then we have 6x minus 0. And negative 6 minus 0. Is that degree less than the degree of the divisor? Then we have to keep going. What do you multiply x cubed by to get negative 4x cubed?
4.
Negative 4. Negative x squared plus 2x plus 2. Is that remainder, or sorry, is that degree less than the degree of the divisor?
Yeah.
Then we're done. Again, it's just tedious, not necessarily difficult. So there is good news and there's bad news. The good news is technology does this. Bad news is you're not allowed to use it. CAS will do this for you. Of course, you're not allowed to use the CAS, so There's more good news though. Most of what we're going to be dealing with will look like this.
Bless you.
Isn't d of x of the form x minus k? Synthetic division. When finding zeros, it's usually synthetic division that you use. So here's how synthetic works. First, you look at the divisor. What is k? It is not 2.
Positive 2.
Not positive 2. Remember, it has to be of the form x minus a number. So that is x minus what?
X minus negative 2.
Your k is negative 2. For the next part, it's very important that your dividend be written in standard form. What standard form?
Isn't that a standard form?
That's what I'm asking. What is standard form for a polynomial?
Descending from the highest degree.
That's true, and there is one other condition. That'd be standard form.
No.
What's wrong with it? So that's descending order. That would be x minus 1 to the 4th expanded. Is that standard form? That is also not standard form. That 2 also has to be distributed through. So standard form is of the form a sub n x to the n plus a sub n minus 1, x to the n minus 1, plus so on and so forth. It has to be fully expanded out and in descending order of powers to be standard form. Once you make sure it is in standard form, you now just write out your coefficients. First coefficient drops down. Multiply that by -2. What do you get? Add them. What do you get? Multiply by -2. Add them. Times -2. Add them. In synthetic division, that last term is always your remainder. The degree of your quotient is 1 less than the degree of the dividend. So what is the degree of our quotient going to be? I'm just looking for degree right now. What's the degree? One less than the dividend. It's a second degree polynomial. These are your coefficients in descending order. And then your remainder is always going to be constant for synthetic. So synthetic is a lot easier. It's also a lot quicker. What's K? What is it? That's not K. I agree, that's your divisor. What is K though?
What does K stand for?
So your form of the divisor for synthetic has to be x minus K. What's K?
4.
Is your dividend in standard form? What are your coefficients?
-3x. 5x.
That's not the coefficient.
Oh, 10, 15, and 18.
Keep going. What was it? 10.
15, 18, -6.
Happy with that. It doesn't mean you're not happy with it. I'm not. What's missing?
Is it like a number to the power of three?
Yeah. You need to placeholder. So it'd be 10, 0, 15.
Would be a 1 or 0?
0. I guess
You missed the coefficient for x cubed originally. This is the biggest hiccup made in synthetic division. In polynomial long division, you can get away with not including the missing terms. You cannot get away with it in synthetic. So not only do you have to look at the coefficients, you must also pay attention to if there are any missing terms. Which in this case there was, x cubed was missing. Now we can perform synthetic. -3 drops down. Times 4. Plus 10 times 4 plus 0 times 4 plus 15 times 4
-68.
plus 18
-50.
times 4 plus -6 degree of the quotient is what? Write it down here then. There's the quotient, there's the remainder. For polynomials, what has to be true about the coefficients? like that, is that a polynomial? Would that be a polynomial?
Is it like rational? Is that the word?
So you're saying the coefficients have to be rational? Do that. So those are polynomials. Your coefficients just have to be real numbers. That makes division fun. So we've been looking at integer coefficients. Nowhere does it say your coefficients have to be integers. Here we're still being nice. At least the dividend has integer coefficients. What is K? One half. Is the dividend in standard form? What are the coefficients? Two times a half. Add -5.
-4.
Times a half. Add 6. Times a half. Add -3. Oh, wasn't that nice? What's the degree of the quotient going to be? There's your quotient, there's your remainder. What's K? What is it? Dividend, is it in standard form? Coefficients. Three drops down, times 2/3.
Two.
Add 8.
10.
Oh, okay. Well, this isn't what it's supposed to be, but this will work. It's supposed to be plus 2/3, not minus 2/3, but do this. Times 2/3. Add -1 to it. Times 2/3.
This is 34 to 9.
I like this one better. Add 7. Times 2/3. $194 over what?
That's 2.
Oh, but by the way. No, never mind. I was thinking something else. I thought that could be reduced. It can't. That's a bummer. Now add it to 2. Oh, you don't need a calculator. So you told you didn't need a calculator. What's the degree of the quotient going to be? Keep in mind too that that was still with the dividend having integer coefficients. Imagine how fun this gets if you have rational coefficients. or even better, irrational coefficients. So notice what it's now asking. It's not simply just asking for Q and R, is it? Can we perform synthetic on this? What's K? Just -4. Coefficients of the dividend.
Plus 50. Plus 50.
One times -4. Add -2. Times -4. Add -24. Times -4. Add 15. Times -4. Add 50. What was the divisor? What's the quotient?
X cubed minus 6x squared plus 15. Remainder.
What's the remainder? Oh, by the way, this is going to show up again in calculus too. Just you obviously will then go further in calc 2. And also, it's very unlikely in Calc 2 that it'll be synthetic division. It'll most likely be long division you have to perform. And then write it in this form. Actually, so that's a typo on my part. It wouldn't be over d of x. That's if I decided to ask you to write f of x over d of x equals. So what was my intention here? I think it was to ignore that d of x out there. I think we're just to write this q of x plus r of x over d of x. I think that was the intent. So ultimately what we're doing is we're looking here. You divide everything there through by d of x. That's what we get. Not dx over here. D of x. That's what you would get if you divide everything out by d of x. And that's the form that you'll be using in calc. Which means all of these slides have to be updated. But that's not hard to do. Can we use synthetic? What is k then? Coefficients of the dividend. Like that.
No, it's another 0 and then minus 4.
2 comes down times negative 3. Plus 0 times negative 3. Plus negative 17 times negative 3. Plus 0 times negative 3. Plus negative 4. This would be f over d, just to keep everything consistent. What is our quotient?
2x to the 4. Plus x minus 3.
And the remainder? over the divisor.
minus x plus 3.
Synthetic, can we use it?
Yes.
What is K? What are the coefficients?
1, negative 10, 1, and 1.
4 times a half. Add negative 10.
Minus negative 8.
Times a half.
Minus negative
Add 1.
3.
Times a half.
Negative 3 over 2.
Add negative 1.
Negative 5.
What's the quotient?
4 x squared minus 8x minus 2.
And the remainder?
Negative 5 over 2.
What's the divisor?
X minus 1.
Now what's the problem?
It can't be negative in the denominator.
Yes, again. What's the problem?
It's supposed to be plus R.
Well, if R is negative, then it just becomes minus, so that's fine. That's still plus R over d of x.
Is it the fraction in the denominator?
Just the fraction of the denominator. And where? So you're right. You're honing in on the right term. That's the problem. You're right. Even if that was 5 over x minus half, that would still be a problem. Oh, I didn't want him to do that. That's not what I wanted to do. I like it when it doesn't show up, does it? That does. What's that known as? I need a really good highlighter colors. Ooh, that worked. No, see, even that doesn't work. That is the only one I can do. Actually shows up. So what kind of fraction is that known as? Making your algebra instructors very, very sad right now.
Less.
Actually, I think you learned this even before algebra.
Is it improper? I have no idea, I'm just saying.
So no, that is not improper.
Okay, cool.
Improper is when the numerator is larger than the denominator.
Okay, yeah.
Or in the case of rational functions, improper would be if the degree of the numerator is larger. So no, that is definitely a proper fraction. Would you be allowed to have something like that? No, you wouldn't be, right? What is that called? So there's two names for it. I would accept either one. Past math instructors are crying right now. It's a compound or complex fraction.
What does that mean? That's just, okay.
Your numerator and denominator have fractional components. So that's a complex fraction or a compound fraction. They mean the same thing. And so it's a fraction and a fraction. Right? Not allowed to have that. That is a huge no. means we have to simplify it. How do you simplify a complex fraction?
You just put the 2 in the numerator and the denominator.
Why 2?
Distribute it. Because 5 divided by 2, like, I know it's not so.
So what if it was this instead?
So then it'd be 5 over 2 times x minus 1/3 on the bottom. I don't know, I might be completely wrong. Yeah. You can't just put the 2 on the bottom.
There would be a problem doing that. Because you're right, you can, but then you have 2x minus 2/3, which is still compound. So that wouldn't work.
It would be like separating 5 over 2 times the reciprocal times.
Right, what's the reciprocal of x minus 1/3? 1 over x minus 1/3, which is the same thing.
I was thinking do anything.
1 over x, yeah, so it's the same thing. Oh, absolutely not. We never use decimal form unless we're asked to. But that would still leave you with the same problem. 2.5 over x minus 0.5 is still complex. Multiply numerator and denominator by the LCD, which in this case is 2. In the case I had written above, it'd be 6. That'll clear out the fractions. 5 halves times 2. And then x minus a half, distribute the 2 through. You get minus 5 over 2x minus 1. So let's do a little thought experiment. I guess it's not really going to be a thought experiment. But you shouldn't have to do a lot of work. Perform that operation. What's your quotient?
Why are they boarding my ship?
You get the question. Now look at the original quotient. What's the remainder? Negative 5 times. Oh. Which again is half the remaining $3. That should give you some kind of clue how you can use synthetic division for linear divisors that do not have a leading 1. But again, I'm not going to focus on that in this course. Questions on dividing polynomials? Let's hope not, because it's going to be very important. Because the next thing we look at is the zeros of a polynomial. Finding the x-intercepts. Again, it's not a necessarily difficult process. It's actually very easy. is just extremely tedious,
Bless you.
especially if you're unlucky, because it involves guessing a little bit. But it will involve synthetic division. And in fact, involves several theorems, so several steps that we have to look at. That is what we look at on Wednesday. Your first quiz will go live after this class, and will be due next Monday before class starts.
This is really good for that, that's it.
I don't remember if I have it set to go up at 11:40 or 11:50, but by noon it will be up there. And it'll have to be done by 10 a.m. next Monday. It'll be done completely on Blackboard.
It's all the same thing.
Is it on science league or what?
It's on Blackboard. It's not on website. So you'll submit it on Blackboard as well.
Yes.
And then, oh, why is that not on here? That should, that's an oversight.
Yeah.
Your first exam is also next Monday. And yes, it will cover what we do on Wednesday. See you Wednesday.
No, we got to go off.
You guys are going.